Let me introduce myself. I'm Virag Chavan. I lead the NVIDIA GPU cloud compute, container technology, and Kubernetes here at NVIDIA. So the name of our title is, the topic is the path to GPU as a service in Kubernetes. The path begins with understanding how our users are using GPUs. And as you can see, they have a number of experiences when they start using GPUs on nodes as well as on clusters. So we keep on hearing things like, look, we don't want to deal with dependencies. We really want this to be a plug-and-play kind of architecture so that we can focus on building our deep learning models or run our applications. I don't want to deal with different operating systems, and the industry solution to that has been containers, as many of you might be aware. The other part that, as the computing capability increases, the deep learning users really want to scale their applications to take the advantage of the compute capabilities at the cluster level. So this is the feedback that we get from our users, and this is what you see on the screen. This boils down to two things. Yes, we don't want to deal with dependencies, so we are going to use containers. But then GPU support inside containers has always been a challenging thing. So that's one of the things that we want to tackle. Support for GPUs. The other interesting development that has happened over the course of the last several months and years is that the container runtimes themselves have evolved. There is Docker, there is Singularity. There are other runtimes that are being used for other application domains like deep learning, HPC, among others. So that's the first use case that you see in there. And the other use case that's come forward as a summary is that, hey, we want to scale this out at the cluster level. We want the same GPU support for all the functionality that's available for CPUs at the orchestration layer. All the cool stuff that comes with the container, cluster operating orchestration systems, we want them to work for GPUs out of the box. Pretty steep goals. So we are tackling this at multiple levels. We start with tackling our first problem where we really want to give first-class support for GPUs inside containers. We also want to make sure that the container technology for GPU evolves as the container runtimes themselves evolve. What you see on the screen is how we've re-architected our NVIDIA Docker 1.0 container technology to support these goals. What you see is that we not only support the OCI compliant runtimes like Docker and Cryo via a runtime interface, but we've done it such that even the non-OCI compliant runtimes that you see on the other side, like Singularity, can also work with our container technology. So all of you out there who are working on building applications on top of containers, we would like to work with you to make this happen with the work that we are doing on the container side. Which brings us to the next part. How do we scale this out? Kubernetes is an example of a container management and orchestration system that's widely popular. It allows you to scale up at the cluster level on several key dimensions. Security, logging. You really want some intelligent scheduling to build in your application logic. As described in the keynote earlier in the morning, self-healing clusters, multi-region clusters, that's where really you want to scale up your applications on. And provisioning GPU clusters in this paradigm is a challenge for many of our users. And this is something that we want to talk about in our current talk. NVIDIA has been really focused on making GPU capabilities available in Kubernetes from very early on. Back in July 2017, as Kubernetes itself was evolving, the GPU support was really experimental. You had to manually mount your volumes in your pod spec in order for your deep learning applications to work. There were no GPU monitoring metrics that were really useful or available to our users. You could definitely hack around your way, but the out-of-box experience was not just there. Fast forward to December 2017, we introduced two main improvements to this. NVIDIA Device Driver Plugin, which was alpha at the time, and as of yesterday has been promoted to beta. So kudos to the team there. Really exposes the GPU as a first-class resource to all the software components on the top of the stack. This has really unplugged the way we can add more capabilities for GPUs going forwards. The NVIDIA container runtime architecture that I described earlier on is now a part of the upstream Kubernetes effort. Now, this has really enabled our users to switch between the different runtimes, and this is something that we continue to evolve in terms of the features that can be made available using our re-architected container runtime. What you see on the extreme left is really, there are a lot of things that we think we can still add in terms of GPU features. Let's go over it a bit more so that we can share some context, and Renaud will do a deep dive on some of these features going forward. GPU monitoring features, we really understand GPUs very well, and there are a host of features that we want to expose to our users. This will help our users kind of fine-tune their applications. Let's say there is a bad GPU or there is something that's throttling your application. We really want this to be available at the scheduling level so you can use some of that data to fine-tune your applications. Our users are moving towards different types of GPUs on different nodes, and clusters are increasingly looking a bit heterogeneous. We want to add these capabilities where you can now schedule your job taking these constraints into account. For example, you can choose to say, my application needs this type of GPU and this amount of memory, and we want to kind of make these capabilities available. MPS support has been a huge ask from many of our customers and our partners. This is a very important use case for inferencing, and this is something that we are looking into as well. As described in the keynote today morning with DGX2, we can see increasingly complex topologies, and we want to be able to expose them at the Kubernetes layer for you to customize your applications even better. We continue to invest in the device plugin that I talked about earlier, and Renaud will talk in more detail, which kind of talks about what we want to do next there. All these features are something that we are actively working with the community on. So we really are looking forward to work with all of you to take these features upstream and bring this advantage in front of our users. Having said this, I'm going to hand off the control to Renaud, who is the lead Kubernetes engineer on my team, and he's going to describe the features in more detail and what we are doing with them. So Renaud?
Yep, thank you. So hello, everybody. So if we look a bit at the features that NVIDIA is really invested in, and we look at the most important ones, for example, GPU monitoring. And if we currently look at upstream support for GPU monitoring, it's a bit basic. It only reports GPU utilization, memory usage. And so we're looking with the community at exposing more metrics to the end user and the cluster admins. For example, as a cluster admin, we would like to be able to expose and identify badly behaved and unhealthy GPUs, and mostly be able to detect the power inefficiencies and the different, and just see the different power consumptions of your GPUs in your cluster. And for users, it's really important for us that they are able to see what are the different metrics, what are the bottlenecks and the GPU throttling to diagnostic their applications. Sorry. So GPU monitoring is a big feature that we're pushing for currently in the upstream community, but there's also support for heterogeneous clusters. And currently, it's a bit difficult for you to express, for example, requirements on your GPUs if you look at the upstream support. You have to manually label your nodes. You can't really express, for example, I want this minimum amount of memory for my GPU task, or I want for my GPU inference service ECC to be turned on. And we're looking at pushing that upstream. And also, a problem we're trying to tackle right now is the runtime support. So currently we support Docker and CRIO, but we've got some bugs that we have upstreams, and we want to fix them. So for example, right now, when you're setting up your GPU cluster, it's a bit tedious because you have to set up the NVIDIA runtime as a default runtime for Docker, for example. And this is a big problem because that means that all your tasks running on GPU node will actually use the NVIDIA runtime. And if you run NVIDIA images without requesting GPUs, well, your NVIDIA images will have all the GPUs exposed because we're not using the NVIDIA runtime only for tasks requesting GPUs. So in 110, we actually have full CRIO support, so that's a big first step. But we're also looking at Docker and containerd support. And if we look at the customer use cases and the features we're discussing with the community and we would like to see, as Viraj was mentioning, we're really looking at GPU sharing because Volta is something that has this really important features that allows you to run multiple inference service on your GPU. And we want you to be able to use the full Volta capabilities. We want to have you save money and not have one GPU per container. We're also looking at GPU topology. So as Viraj was mentioning, we're exposing more and more complex GPU topology, DGX-V1, DGX-V2, and we want you to be able to have your application run as fast as possible and not be limited by some GPU topology that requires you to take, for example, 8 GPU when you only need 6 GPUs because you want to go around the NUMA problems. So if we look a bit how we actually got to the Kubernetes GPU support, in 1.6 and 1.7, this was a bit experimental. In 1.6 could only support 1 GPU per node. You actually had to manually mount your libraries in your container, and this was a bit brittle because that meant that you had to ensure that all your nodes exposed your libraries at the same place, and when you were upgrading, that meant that you actually had to go through the same process, and sometimes that would break. The GPU support in container was really fragmented at the time, so we had NVIDIA Docker V1 for Docker, Kubernetes had its own support, and Singularity was going its own way too. So that was another issue that we were having, and as we were mentioning, you don't have metrics or health check in Kubernetes 1.6, 1.7, which leads to really weird bugs where if you have one GPU in your cluster that's bad, and you launch a few different GPU tasks, well, your GPU task that is going to take that GPU is going to fail, and then it's going to, Kubernetes will make sure that your GPU task gets paused for 5-10 minutes, and then run the other GPU tasks. So you end up having a GPU that acts as a black hole and fails all your tasks. So this is something that we actually fixed in 1.8 by introducing the device plugin. So the device plugin is a generic system that allows you to enable certain device or capability as a plugin in your cluster. So you deploy a plugin on all your nodes, and it exposes the device to the cluster for your GPUs as almost a first-class resource. It also allows us to set up the device, so for example, install the driver, and it's an important part of your container runtimes. It makes sure that that we expose your GPU correctly inside your container. If we look a bit at the life cycle, what that means is your cluster admin is going to deploy your device plugin on your cluster when he wants to, for example, expose GPUs. Your node is actually going to create the different containers of the device plugin. The device plugin will then install the driver, register itself against kubelet, and one of the things it's going to do is, for example, list the devices or ask the NVIDIA device plugin to list the devices. And what happens is, for example, your device plugin will list 3 GPUs. If one GPU fails, it will notify the kubelet, and the kubelet will actually expose that in its node status. One of the things we're pushing for is metrics inside your device plugin so that we can actually expose that to the cluster for example, as part of C-Advisor or Prometheus. And this is the broad device plugin lifecycle. If we look a bit into the container lifecycle, one of the things we're pushing for is, as a user, when you create a pod, your node gets selected, your pod lands on the node, devices get selected. Your node is going to issue a pod admission call and then issue different calls to initialize the container before the container starts. And then if your pod is deleted, you'll have a call. So this is really important because we want to make sure in the NVIDIA device plugin that your container always gets the same, its device in the same state, so that if your device is in a bad state, your container can't run. And it's also important because we want to make sure that as Kubernetes moves to a multi-tenant cluster, well, if you get a GPU that another tenant has used, we want to make sure that you can't access that GPU memory that the other tenant used. And so these are the steps that we want to make, we take in the device plugin to make sure that the GPU you get are in a good state and are secure. So if we look also at the registration system that we're pushing for, we're looking at a zero downtime system. This is really interesting because, for example, say you deploy a device plugin on a cluster. It's 1.8, let's say. And it goes through the registration process, so it places its socket in a known or agreed upon directory with kubelet. Kubelet goes through a validation process and then exposes that device to the cluster, and then the device plugin goes through its whole life cycle that we've just presented. So say now that your cluster admin wants to actually deploy the NVIDIA device plugin 1.9, so he upgrades to a new version. You deploy the NVIDIA device plugin 1.9, it will once again place its socket in the directory. Kubelet will go through the validation phase, and once it's actually finished through the registration process, it closes the connection with the NVIDIA device plugin 1.8. This is important because it allows you to do zero downtime and, zero downtime. Another interesting point or use case that's possible, say you want to enable ECC on your GPUs. You could, for example, annotate your node and say, I want ECC enabled on that GPU. The NVIDIA device plugin watches these annotation, enables the ECC on the GPUs, and then re-registers itself against kubelet, and once again, zero downtime. So all that ties up to GPU as a service. And so this is a set of different recommendations that we've seen, and this is how we deploy GPU applications. It's one of the important features that Kubernetes allows you to is scale and resiliency. And it's important because GPU basically is now part of these features and it plays nice with them. So if you look at scale, for example, there are different ways to do it. You can actually manually set the replica count like we've seen this morning. Or more interestingly, you can actually deploy a horizontal auto-scaler. And so a few questions we've seen from the community is, how do we scale? What is the metric that we're going to want to scale on? People were looking at GPU utilization, CPU utilization, maybe CPU or GPU memory. What we usually say to our customers is, you want to scale based on what the end user sees. So query per second, or for example, how long a query is going to take. And resiliency, you actually look at a few different things, such as the liveness probe, which allows you to actually make sure that your Kubernetes sees how your application is, what state your application is in, and then always make sure that your restart policy is at always. So this is interesting because we actually want to push that with the community. If we look a bit at how we've actually moved in the community, and we started in February 2017. Basically, we've discussed with design proposal, and we've gone through a face-to-face meeting in spring. The first design document was merged in summer 2017. The device plugin made it in 1.8. It is now in beta since yesterday. And we're hosting the face-to-face meeting at NVIDIA on Thursday and Friday. And with that, I'll let Viraj finish.
So we are at a very exciting point with where Kubernetes is headed, where GPUs are headed. And keeping that in mind, of course, we have a lot of work to do. So we are going to continue to work with all of you and the community to bring the GPU features and enhancements to our users.